the strategy that Backrs uses for their main application is AWS Lambdas, which are very good at horizontal scaling automatically. One of the big considerations is the usage pattern of our apps is very much spikes. One, because there are usually some onboarding sessions that happen, a whole school potentially, 400 people potentially, all signing up at the same time. And so you need to be able to handle those spikes without spinning up like 100 EC2 servers that are on 24 hours a day and just like wasting a bunch of money on it. So that's where Lambdas came into play. They work very well.
All right. Well, welcome everybody. I'm Aron, CTO of Olio Apps.
Hey, I'm the CEO of Olio Apps.
I'm Josh, producer of the Code and Cognition podcast.
Yes. And Zach, you are our honored guest. Like to introduce yourself?
Sure. Yeah. So I'm currently a software engineer at Backrs, one of Olio Apps' long-term partners or clients. I work specifically on our LLM product for Backrs. We call it Bubov. Been here for about a year. My academic background, I don't even know if you know this, but I started as a civil engineer. Actually, I have a bachelor's in civil engineering. Yeah, so a bit of a departure. I got out of there kind of as quickly as I could. I always had a very strong interest in software, and basically every job I've had since, through my internships and my first job out of school, I just like tried to make it as software focused as possible and kind of just jump ship as quickly as I could. And now just like full time in software and in AI. So I worked initially when I started in data science and machine learning. I was very much focused on kind of the intersection between civil engineering and data science, which to me, the thing that made the most sense is geospatial data science, which takes GIS, anything geospatial, so satellite imagery, GIS, and doing statistical analyses and model development on that. So I worked a few internships and a job that was focused on that. Did a master's degree, which was very much focused on geospatial data science, doing predictions, developing models to do forecasts of things like weather and mine specifically. My research was in sea ice. From there, got really interested in AI. I mean, that was all AI focused. And with LLMs kind of taking over everything, I now do most of my work or all of my work using LLMs, which is definitely very different from actually developing machine learning models or more software engineering than it is modeling when you're working with LLMs. But that's where I find myself right now, building cool products with LLMs.
Oh, I see. Yeah. It's definitely news to me that, you have a civil engineering background.
Yeah.
Cool. And that's all. What's awesome too is that Scott had early intersections with GIS also, right?
Cool.
Yeah. Did a mapping marketplace back in the day for scientific data.
I like how you talked about the distinction, right, between what you did. Your background was like actually building models versus it sounds like application development using some models, the AI models. So I suppose that would be the primary difference with what you did then versus now.
Yeah, for sure. And I find them personally to be completely different things. So there's like levels of working with AI, in my opinion. There's the very ground level way where when you're developing, say, new architectures of models. So you're working with like trying to figure out what's the next transformer, right? That's like ground level. That's real, deep data science, deep AI research. My master's research was applied AI. So it was using building blocks that people have already developed and kind of piecing things together to develop new architectures, but still using things that have already existed. So it's kind of like playing with Legos, putting things together, which I found to be a lot of fun. And then there's real straight application of AI, which is taking models that have already been trained, that have already been, these huge models, and taking those and doing something useful with them. So that's the primary difference. And I mean, the big difference is like when you're working with LLMs, almost always you're just using an API. You're using a model that's already been trained, these huge models that big tech companies have trained, and then either fine tuning them or, doing some custom implementations, maybe a few added layers of complexity, but very much just using those and to make it useful for your business case. So it's a lot more software engineering, a lot more just putting things together, putting different APIs together, connecting it to your data and getting useful stuff out of it. But almost never do you actually start training a model from scratch.
And certainly. Yeah, Scott and Josh, do you have any questions or comments there?
I know I'd love to hear a little bit, just a tiny bit more in terms of if there's anything that you are still taking from your civil engineering background into the world that you're doing with LLMs, or there's any strings of continuity there, or do you think it's helped, given you a unique perspective or insight?
Yeah, I think it has. And then I guess at a basic level, what a degree in engineering, any engineering discipline is going to teach you is problem solving. And I think that's what I carry forward, is a very pragmatic view. So although, I did a lot of research and a lot of stuff has been, a bit academic, I still take my roots in civil engineering, thinking about pragmatic solutions, not needing to be a perfectionist or a scientist in every decision, but just like, let's try to make things work. Let's try to problem solve. I think that has carried forward from my previous work.
That makes total sense. Speaking of your work, could you describe like some of the problems you're applying, like how you specifically applied the large language models to what problems in Backrs you're solving, like most recently even?
Yeah, the use case, like the reason we're using LLMs is we want to have a hyper-personalized experience on Backrs. So we want a user to be able to log on, look through all of our tools, the information that we have, and get advice that is hyper-personalized to their situation. Because, the platform is meant to help students and young professionals get ahead and learn about different career paths, learn, what skills they need to get to kind of just achieve what their ideal life is, essentially. And so we go through the process of first helping students find like, what kind of life do you want to lead? What kind of career do you want to have? And then from there, we help them get the skills and do the things that they need to do to get there. And if we had just, a platform that was, one set of advice or, a set of advice that applies to like 12 different types of people, that would be not very helpful. You could just read a book, right? So what we try to do is make it hyper-personalized. You upload your resume, you tell us about who you are, from demographic information to like what specifically interests you, say in software engineering or any other discipline. And then we take some content that we still have curated, but we take that and then we can hyper-personalize that to you. And how can you apply this blog post that we think is useful, but how is this actually applicable to you? To kind of try to convince you to read it and then get some advice that's very much for you, and not just like a blanket advice that applies to everybody. That's why we use LLMs.
I see. Probably to generate the advice and also to match up the advice with the people and their specific context.
Yeah, exactly. And it's really good, and you can do this a lot of the times, so if you read an interesting blog or something, you could take that blog post, upload it to ChatGPT or any other LLM, ask questions and get a deeper understanding. What Backrs does, it kind of just makes that process easier. So instead of having to take that blog post and then upload it and tell that LLM everything about yourself, we've got all of that already. All you have to do is read the post and then you can start asking questions about it and you get a deeper understanding and specifically how it applies to them.
Makes total sense. Yeah, it makes that process much easier, and doing it at scale for large populations of students. And that's where a lot of the secret sauce is, right? To make that work.
For sure. Yeah.
So really what you're talking about is applying Gen AI application development at scale. I would say like we are actually applying this to the cloud, right?
Mm-hmm.
Yeah, maybe we can talk a little bit about what some of the challenges were to take it from a prototype, right, to initial deployment, and then in preparation for larger scales. So maybe you want to talk about your journey, how this happened?
Yeah, sure. Yeah, so the whole system really started out very much exactly as you described, very much a prototype. I was working on contract part-time, we wanted to see if this is possible, if this is something that could be helpful, if people liked it. So we built it as a prototype as quickly as possible with really no thought about how to scale it, because we just wanted a proof of concept kind of thing. And so the easiest way to do that is to prototype on local, right? You get something working on local, and then you spin up a server on the cloud, spin up an EC2 server, stick it on there, and then start making requests directly. That worked when you have 4 people maximum using that system. As soon as you decide, oh, this is actually a useful product, people want to use it, suddenly you need to think about how is this going to behave when 100 people use it. And what we quickly find is there are very much limitations to using a single server to serve 100 people. You're going to have long wait queues and things are just going to kind of just blow up. And so the strategy that Backrs uses for their main application, the app that is currently in production, is AWS Lambdas, which are very good at horizontal scaling automatically. And so I guess like one of the big considerations is the usage pattern of our apps is very much spikes and what do you call that? I guess you get big spikes. One, because there are usually some onboarding sessions that happen where a classroom will say, okay, we're all going to sign up to Backrs now. We're all going to try to use it. And so you get a whole school, potentially 400 people, potentially all signing up at the same time, all testing things at the same time. Once that session is over, it goes back down to zero. And then secondly, because this is used in an academic or an education setting, we're going to have large spikes during the day, right? During school hours. And so you need to be able to to handle those spikes without, spinning up like 100 EC2 servers that are on 24 hours a day and just like wasting a bunch of money on it. So that's where Lambdas came into play. They work very well. They scale. We can, if we know that there's a session that's going to happen tomorrow, we can ramp up the number of Lambdas that are alive and warm for that period and then spin it back down. It also does automatic scaling. And so we don't even necessarily need to do that. We can just let it run and AWS kind of just handles all of that and we'll scale it up, scale it down. So we did the same thing for the AI application. There are some gotchas that happen when you do AI and LLM API calls using Lambdas. The first is Lambdas are usually supposed to be used for short-term functions. So you make an endpoint call, it will do whatever it has to do. Once it's done, it spins back down. If you have an API call that does a bunch of complex LLM tasks, so say it's an agent that does like 5 different that's because of 5 different agents and they all do a task and then they come back and then you get a final response. That can take upwards of 20 seconds to run. It could take 30 seconds up to a minute. And so these Lambdas aren't really optimized for that. And so you do need to have some special configurations to allow it to have these long-term or to keep them alive for that period of time while things are processing. The second thing that we ran into is with streaming. Streaming sounds like it might be an easy thing to do. Turns out with AWS Lambda especially, it is kind of tricky. Especially, and the tricky part is that when you're streaming information, and almost all the time, if you're doing LLM stuff for in a business setting, you almost never just want to get text back. You're almost always using structured outputs where you're receiving a JSON object as your response. You might be doing this for like, if you want to display things in different places, you don't just want text at the bottom, but maybe you want to update something at the top and you want to have, I guess, a real example, like even in a very basic configuration, you have a response in a chatbot app, but you also want to have some suggested follow-ups. And so you'll get the LLM to generate the response and then also some suggested follow-up questions that the user could ask you. And so that already is structured outputs. You have your main response and you have your suggested prompts at the bottom. When you do that while streaming, the tricky thing is that you are receiving a string, a JSON as a string, as a bunch of chunks that come in. And so in the middle of the stream, you're going to have a partial JSON object that you need to handle. And then there's other tricky parts, if you want to inject other things into that response, things like, on an EC2 with an API gateway in front, it's going to inject headers in that response. You can't do that sort of just willy-nilly. You can't put it at the end because then you're not receiving the headers on the first chunk. So they need to be injected at the beginning. So all these tricky things, you need to have on the front end, you need to have some process that takes a partial JSON object and restructures it and ensures that everything is good and the headers are there. And and then displays it in the way that you want to display it. So all of that needs to be kind of configured and thought of, which makes it kind of tricky, but it does work.
Yeah, and just getting an endpoint that is streaming, period, right? Never mind the orchestration you had to do on the client or in the backend even, but just actually having a Lambda that streams responses that does not buffer the whole thing and just give it all to you at once. Just getting that is a little bit tricky. And I think what we ended up using was AWS function URLs.
Yeah,
right.
That's right.
And I had a very similar intersection with Data Pilot as you. I implemented a conversation, basically a conversation interface, a chatbot, and responses would stream through. Doing it on Node.js is pretty. It was pretty tricky, but there was kind of like first class support for streamifying a Lambda, right? There was which I showed you, and eventually I got it to work, right? Where I could use the AWS function, invoke that URL directly, circumventing API gateway, which is got some disadvantages, right? Also, because you have to use the ugly URL. And also there might be some problems with provisioned instances, right? Yeah, so it's difficult to keep several of them warm at a time. That's what I mean. I think we encountered that too.
Yeah, exactly. And those are the weird things that, to me, honestly, it's not super clear why all of these things don't work for streamed Lambdas. But provision concurrency, AWS just doesn't support it. So you can't just have a configuration in your serverless if you're using serverless that just says keep 80 of them warm. You need to have some other process. And what we're going to do, our thinking is, you can just have an event that triggers every few minutes that keeps a certain amount of them alive. Kind of just like a pulse check, which works, but is kind of a little bit hacky.
Yeah, it's a little bit of a workaround.
Yeah,
that is just something people had to know. That's complicated, right? If you want to try to have a streaming endpoint, it will not work well with API gateway. And we have the limitations of easily keeping the instances warm. But then there was an extra layer of complication that we had to get going for the Python version of a stream in Lambda. Do you want to talk about that a little bit?
Yeah, it's not super clear to me why the Python implementation isn't as simple as the Node.js one. But for whatever reason, the most popular way to get a Python, or say like we use Fast API. So to get a Fast API application running on a Lambda, you need to convert it from Fast API into something that a Lambda can understand. So you need to have a handler there. And so the one that most people use for Fast API is Mangum. And that will just take your application. It's a very simple thing. It's a one-line thing where you just wrap your application in a Mangum wrapper, and then it communicates with AWS Lambda very easily. Mangum does not support streaming. You can't do it. You can try. It's not going to work. But there are what we found after going through the archives, doing some heavy Googling, there is an unofficial, I think, AWS implementation for a server that can be run alongside your Fast API that will intercept your events, your calls, and convert that to a way that that Lambda will understand. And that too, in fact, is just a one-line change. You just spin up that server and let it kind of handle itself. But it's kind of strange that it's a kind of an unofficial AWS product that you can stick in there with very little documentation. And to me, it was very surprising that it worked. I thought, okay, well, I'm going to try this just because, we've got nowhere else to go. But it turns out you can get rid of Mangum completely, put in this extra server that intercepts, and streaming kind of just magically works.
If you, Zach, would you happen to have that magical repo like in the browser history because this is like a Hail Mary pass. It's like going through the stuff, we're like, well, what about this? Maybe it might be helpful for some of the listeners, viewers, right? To see some of this. Not necessarily our implementation, but at least like the magical repository.
It's called AWS Lambda Web Adapter.
AWS Lambda web adapter.
It appears to be an AWS repo, and they have these examples, but this isn't anywhere like on the AWS documentation or anything, at least that I could find. But there are some examples in that repo of using it for different types of apps. I think there's a Flask implementation. There's one for Fast API.
Yeah, this looks like it's not just for Python. This is just for all languages.
Yeah, for a lot of languages.
Yes. So the Fast API one was particularly helpful.
Yeah, with streaming response. Yeah.
Yes. If you look at this right here was the magic sauce, right?
That's right.
And so
Are you using it in Docker like this?
Exactly. Yeah.
Okay.
Oh, right. Because we have a Dockerized Lambda Python. Yes.
Yep.
That was another thing we had to do because of the dependencies being so big.
Exactly. Yeah.
Yep.
Yeah. So really all it does is that one line change, that one copy that installs the binary for the web adapter. And
Right
that
there.
sits in front of your Fast API app, intercepts it. Yeah, exactly. That's like the one line you have to change in your Docker file. That
Wow.
installs it. One gotcha actually that I ran into. This doesn't work for, funnily enough, it doesn't work for Lambda, AWS, Python, Docker images. You need to use one that isn't made for Lambda, stick this in, and then it works for Lambda. But you can't use it on the official Lambda Python Docker image.
Well, this smells like a blog post in the making for us, like just to really get the details down, I think.
Yeah.
Yeah, I don't know why this doesn't exist clearly in the plane. Probably because there might be other different access patterns for streaming that have more recently matured, like WebSockets that you can do, right?
Yeah, WebSockets, I think, is how most people will do this. This was a straighter path for us on Lambda.
So that was an exciting find and frankly a hallelujah moment for us, right? When it's like, oh wow, it just kind of works. Fantastic. Yeah, it's a great job there. Okay, so now in our story, we know streaming Lambda actually works. The Cloud Functions, we got it deployed in the development environment. Everything works and you kind of test it one at a time, right? One user at a time. It's great. Now, do you want to talk about the journey we took from trying to get like 100 one user to 100 concurrent users? Because there's going to be 100 students like logging in and trying it. Like what that looked like for us. And literally this morning.
Yeah. Yeah. I mean, so the big issue that we ran into is actually with database connections. So a lot of the times, especially if you're using Lambda, Lambdas are stateless, right? You can't be storing anything as a state and then retrieving them. You need to have some sort of database or it needs to be written somewhere. For example, just like the conversation chain. If you're sending hi, and then how are you? Every time you send that, you need to load the conversation back in. So the way that we do it is just straight up writing it to a database. And so every time you send a message, it loads that conversation up, pings the database, and then there's some other database calls that happen as well, especially if you're doing things like retrieval augmented generation. You need to be pinging databases all over the place, a bunch of queries happening. When you have 100 users using it simultaneously and you're using AWS Lambda, you're spinning up 100 different Lambdas, 100 different instances that are all making these calls at the same time. And so you need to make sure that each one of those Lambdas isn't creating its own database pools. And that was the mistake that we had made originally, was each one of those Lambdas, because we're originally on EC2, we're using a database pool. Switch it to Lambda, we kept that database pool. And so each Lambda was each creating 20 connections.
Oh yeah.
And that very quickly blew up our databases. So essentially all you have to do is make sure that you have a proxy that sits in front of all your Lambdas that manages those connection pools, and each one can pull from the same pool. And that is essentially how we fix that issue. And right now we ran a few tests with 100 users, no problems at all.
Yeah, straight through, right? And that's a much happier result than even our existing implementation, which had, the EC2 version, which was definitely sludging down. So
yeah. If you're using a single EC2, you can have a lot of cores on a server, and so you can have like 8 different workers, for example. And so that can handle maybe 8, maybe 16, maybe a few more users. But as soon as you have 100, you're going to have a lot of queues, very long queues. And so current staging uses EC2. It can't handle 100 users. Lambdas now can.
That's because of the RDS proxy. in the front.
So it's because of the fact that we can spin up 100 of them.
Plus, having 100 different concurrent Lambdas running. Yeah.
Yeah. And then each one of those using the same connection pools that allows for 100 users to be able to use it.
Then we're still working on hundreds to thousands of scale, concurrent user scale, but that's like, at least we're broken out of the initial thing, right?
Yep.
This is all part of the kind of like environment refresh we talked about in the last podcast, right? Being able to scale using Lambdas.
Any scaling issues with like quotas of the LLM provider?
100%.
No.
I mean, we ran into that so fast. Like that was the first thing that we addressed. We use OpenAI. They have very strict rate limits and they don't allow you to just pay more for more usage. You start off on the first tier, and as soon as you send like 100 requests in the span of like 10 minutes, they're going to rate limit you. So the only way to get around that is to use the API a lot. And so literally what we did was I ran a script that just got OpenAI to generate, I got it to generate a story about about my coworkers, that generate a story about Tom and all these people. And I got to generate that thousands of times overnight just to get us to the higher tier. So we just wasted like $200 just to get to a higher tier so that we wouldn't reach those rate limits.
And you can't just give them $200. You have to like cleverly exercise the API.
Yeah, we tried that. We put in a bunch of money and they said, no, you're still in tier 1. You need to actually use this API to be bumped up. It's very strange.
I guess that makes sense because they don't want to just give it to someone who's just going to like park it or like pay the money but not using it, and then no one else is able to use it.
Yeah, if that's how they do it, if they have some sort of like reserved.
I don't know. I'd be like, pay me the money even if you don't use it.
Yeah, exactly.
Because we've run into this issue with AWS Bedrock or just, even with using like Claude or OpenAI where you're not on a tier high enough for the usage that you're anticipating. So run a script to generate a story about your coworkers. Got it.
Yep. Just be ready to pay a few $100 for that.
At least are you automatically bumped up the tiers? So you
are, yeah. As soon as you use a certain amount.
That's a better story than Bedrock, where you basically have to beg them to please upgrade our tiers, right? At least there's an automatic path of an AI.
Zach, you had mentioned a little bit about one of the first issues, I think, about running it using the agents and running into, issues of latency with the Lambdas of the requests. Could you talk a little bit more about the configuration you had to utilize to get over that? Because I've seen that happen a lot.
Yeah. I mean, Lambdas, the default is that I think it's 30 seconds, right? That they don't allow you to run a function that takes longer than 30 seconds to run. They actually make that configurable. So you can just go and set a higher timeout. And that's essentially all you have to do is just set a higher timeout for that. It's not super complicated.
But if you don't do that, is it 30 seconds or 6? Oh no, it is 30 seconds for non-API gateway. Non-internet request facing ones, right?
I think so. Yeah.
What's the max you can boost it to?
Don't remember. Is it 3,600 or no, maybe is it 300 seconds?
15 minutes, I think, right?
15 minutes. Okay. Yeah.
Something like that. Yeah. So high.
Oh yeah, I know that was like the max for like Lambdas altogether. And I guess if you're not using API Gateway, because API Gateway has like a 30-second limit or something, but if you're doing function URLs, that probably doesn't apply.
It doesn't apply. It's much longer, but you have to set it, right? But some other things we had to do. I mean, there's also the possibility that your Lambdas can take over all your quota. Right now, there's a 1,000. I think there's a default 1,000 Lambda limit across all the stuff that if you basically have a background job that uses those Lambdas, then there's no more to handle your requests. I believe that we had to, what's that? Do you recall what that is, Josh?
Reserved concurrency.
So that's another consideration, right? Because though the streaming function might be really popular, it's probably more important to make sure people could log in. So balancing that is another thing that we had to deal with for scalability.
Yeah, for your core functionality, it's pretty much required that you have some reserved concurrency, especially for these because they can be long running, right? You have like, if someone is using it and you have an endpoint that can last like 30 seconds, even if you just have, you might have 1,000 people, that's not out of the question. You might have 1,000 people using it. Then you've got no more Lambdas. You've got no more compute power for to just log in or to do some simple stuff on your UI.
Josh, have you ever been able to get someone to increase the number of Lambdas that are available? Is that something you've ever encountered people trying to do?
This isn't the first time I've heard this conversation happen before. I think, do you know, is it limited by like AWS account or something? Or like how are they determining it? I think you end up getting different accounts or organizations and working with it at that level.
Oh, really?
Or I've heard about people doing that before.
That certainly was something that crossed my mind too.
That's
right?
one way.
Yeah, it'd be very interesting to get a AWS person in here at some point, right? To like plumb them with some of these questions.
Some of these things, I think they're happy to increase for you. They just have some safeguards so that you don't like accidentally blow yourself out.
If you haven't looked at it before, I can't remember if it was Jeff Barr. I think last year they released a great article on how serverless on AWS actually works under the hood, like what's behind that one Lambda function. And it's really incredible. So I can imagine that there's a lot going on under the hood. And so they have to rate limit some of these things, or else there's just not enough computing power to give everyone, more 10,000 Lambda access whenever they want.
Yeah, Amazon's that is big, but not infinite, I think, basically.
Is there any possibility of showing what we're talking about in action of like what your Lubov Lambdas are doing?
This is kind of our dashboard of all the tools that we make available to students. Some of these are libraries of resources that we have curated. Some of these are activities that you can do. Some of these are just like a search bar that you can go and search through internships and scholarships. The ones that are LLM operated, one example would be College Shortlist. That's the one that I think is the most popular. So maybe we can go through that. But that's at the top there. And the idea is you're a high school student and you want to find a list of colleges that you want to apply for. So here you answer a bunch of questions about what type of university you want to go to, where in the US do you want to go to school, here, whether you care about living close to home, what kind of programs are you interested in. So all of this is not yet LLM operated. These are
I was going to say, it's like pretty snappy.
Yeah, they used to be. That's how we started, actually. We had a prototype where we got an AI to come up with questions and then we got your output. That's one thing with working with LLMs is the more that you can control it, the more that you can control your experience, we found the better, just because there's some unknowns about what kinds of questions the LLM is going to ask you. We found it to be not very reliable. So we control the set of questions that we ask you. And then once we've gathered all the information that we think that we need, this will, it takes all the information that you just gave. It'll also take your resume and any other information that you have put into the system through, say, the posts that you've posted on our social media app. If you've gone through any other experiences and you've gotten output from that, we save that and we stick that also as context. And then it gives you a list of universities that might make sense for you. So here you get some safe, target, and stretch, and this is all LLM. It's not LLM generated. It's LLM generated. The descriptions are LLM generated, and the choice of which school to show is LLM decided, I guess. But we have a list of universities that we have deemed to be high quality universities that we only allow the LLM to choose from that selection of universities.
Pretty cool. This is my actual college.
That's so funny.
Yeah, it came out. Yeah, that's great. That's fantastic. And then is there a quick example of streaming?
Yeah. So for that, you would have to go to, for example, go back to the dashboard. I guess you could try, if you have try essay ideas. I think that might be behind there are some where we require you to have uploaded a resume. But try essay ideas right below. Yeah.
There it is.
There you go.
Streaming. Yeah. So see how it's like loading a chunk at a time.
Yeah.
If it wasn't streaming, it was just basically like have to cache. It'll be spinning for like, I don't know, a minute, right?
Yeah. Yeah. And so on the right there, that's an example of a fairly hefty endpoint that we use that takes a while to load. It does like 7 different tasks all simultaneously. It fetches resources and then contextualizes it for you. That's where that personalization comes into play. And so that takes some time to run, but even on Lambdas, it can handle that. So here you get some videos that might be interesting for you based on your profile and based on the conversation that you just had in the chat. If you were to continue this conversation, you could reload those and it'll be more specific to that conversation. And in the blue there, we tell you why you should watch this. Why is this relevant to you and what you're thinking about currently?
Yeah, I can see a high degree of personalization happening and only possible through an LLM.
Yep.
Absolutely.
I love the design too. The college rule notebook.
This is, the top-notch design. It really is. It's like accessible, right? And it doesn't feel like a business site because of the design, even though it's information dense.
Yeah, I like it too. I think it's like balancing, making it look academic, like this is a serious tool, not something that's supposed to be, just like for fun. It's not like scrolling TikTok, but still having some pop of color that like makes it fun to look at and click around.
Yeah, prime the time machine. I want to go back and use this site to figure out where to go to college. This is awesome.
I wish I had it back in the day.
Me too. The way I found out what college to go to, is that I asked the guidance counselor, what's the best college I can go into? Then I just randomly went to Grinnell College, Iowa.
Totally.
That's it. Okay. Well, we're almost at the top of the hour. I just want to say, thank you all, and especially to Zach. Thanks for bringing us into your journey and the specifics of how it goes. So I appreciate it.
For sure. It was a pleasure.
Thanks a lot, Zach.
Thank you.